Hi kids, welcome to Teacher Jean's e-classroom. Today, we will be discussing Science 6, Quarter 1, Week 2 on solution mixture. But before I proceed, please don't forget to like and share my video and of course, subscribe to my channel. So what are expected of you today? At the end of the lesson, you are expected to first explain what a solution is with its characteristics. Second, classify substances as solute or solvent. Third, differentiate solubility from miscibility. And lastly, name solutions commonly found at home. Now let's have a short review of our lesson in the past week. Are you ready? Please get ready with your answer sheet. Get ready with your activity notebook. Write only the answer. Number 1, a mixture is formed when 2 or more substances combine together physically. Is it true or false? Number 2, homogeneous mixture has a uniform appearance. True or false? Number 3, fruit salad is an example of a homogeneous mixture. 4, heterogeneous mixture has non-uniform appearance. 5, there is no visible boundary of separation in particles of heterogeneous mixture. 6, a coffee drink is a homogeneous mixture. 7, solution is an example of a homogeneous mixture. And 8, the particles in a heterogeneous mixture are not visible to the naked eyes. Finished answering? Let's check your work. Let's see how much you have learned from last week's lesson. Number 1 is true. Number 2, true. Number 3, false. Number 4, true. Number 5, false. Number 6, true. Number 7, true. And number 8, false. So, have you counted the number of check marks that you have there? Did you get perfect? Wow, amazing. That's great. Keep it up. Now I want to tell you a story of my life. You know, after giving birth to my 5 kids, I have been struggling with my body weight. I've been overweight and eventually I had some health issues. So I tried to change my diet and have more exercise and have a cup of this herbal tea, which a friend of mine said is very helpful in managing weight. So every day I take a cup of this. What I do is that I put 10 blue ternate flowers in a cup or in a glass and then pour in some hot water. Then I wait for 5 minutes so that the flower's juices may steep into the water. Look at this video. I want you to observe it very well. Observe how the blue colored juices of these flowers move and completely mix with the hot water. Can you see the blue color moving into the water? While the flowers are still in the water, I am able to form a heterogeneous mixture. Can you see that? Why heterogeneous? Because you can still see the flowers there and the water in the mixture. But I have to wait 5 minutes. After 5 minutes, when the water is completely blue, what I do is that I take out the flowers and eventually I am able to get This one. My blue ternate tea. And this blue ternate tea has become homogeneous. And this homogeneous mixture, this one, in these glasses, this is called a solution. So what is a solution? A solution is a homogeneous mixture with one or more solutes dissolved in a solvent. Look at this illustration here. The blue-colored water or the blue-colored liquid represents the solvent, while the yellow ones represent the solute. This is what happens in a solution. You may ask, what is a solvent in a solution? The solvent is the substance that dissolves another substance. Example is water. Siya ang mutunaw sa lain nga substance. So that's the solvent. And what then is a solute in a solution? Solute is a substance which is dissolved in another substance. So ang solute, siya ang gitunaw. Ang solvent, siya ang mutunaw. Ang solute, siya ang gitunaw. There are three kinds of solute. Solute can be solid. Example, salt. Solute could also be liquid. Example, bleach. What's a bleach? That's the one that you use to take out the stains in your clothes. Sample brands of bleaches are Zonrox, Clorox, like that. And for gas, is it possible for a gas to be a solute? Yes, it can be. Carbon or carbon dioxide. So look at our chart here. You see solution, and then the two parts of a solution are the solvent and the solute. So you cannot call it a solution if it does not have a solvent and a solute. So the two components must be there. And the solvent mostly is in liquid phase or in liquid form. But there are also other solvents that are solid and gaseous, but only a few. Most of the solvents are liquid. And this is the substance that dissolves. Example of solvent is water. Another example is vinegar. And another example is acetone. For our solute, we can have solutes in three phases. Could be solid, it could be liquid, it could be gas. And this solute, as I've said earlier, is the substance dissolved. Example, powdered juice, sugar, and nail polish. So in a solution, you can have the solvent, which is water, and you dissolve the powdered juice in that water. Then you have vinegar, then you dissolve the sugar in that vinegar so that you can have a sweet and sour sauce for your salad. Then acetone and nail polish. So you dissolve your nail polish using an acetone. So this is it. You have solution, it's made up of solvent and solute. I have a trivia to you. Do you know that water is considered as the universal solvent? Why? Why is water considered as the universal solvent? Because it can dissolve most of the different kinds of solute. So it's called the universal solvent, that is water. Now let's try to classify. Let's have an exercise. Let's see if you know how to classify the following mixtures, the following solutions as to solvent or solute. So are you ready? Okay, you make there two columns, one column for solvent and one column for solute. Are you ready? Let's begin. Number one, a glass of water plus a drop of ink. Which one is solvent and which one is solute? Start. Number 2, a teaspoon of sugar plus a cup of vinegar. Number 3, a cup of lemon juice plus a tablespoon of honey. 4, a pitcher of cold water and a sachet of powdered juice. 5, a pinch of salt and a bowl of chicken stock. What's chicken stock? That is the water with which you boil the chicken in. Then you take out the chicken meat. What's left to you is the chicken stock. Then number 6, some molecules of carbon dioxide plus a bottle of water. Are you ready for checking? Would you like to know whether you got it right or you got it wrong? Ready? Let's start checking. So here are the answers. Under solvent, we have a glass of water, a cup of vinegar, a cup of lemon juice, a pitcher of water, a bowl of chicken stock, and a bottle of water. And under solute, we have a drop of ink, a teaspoon of sugar, a tablespoon of honey, a sachet of powdered juice, a pinch of salt, and some molecules of carbon dioxide. Count the number of check marks. If you got perfect, that means your score is 12. Did you get perfect 12? Wow, that's amazing. Do you know the nice clap? N, 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 I, C, 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 E, E, E. Nice, nice, nice. Very nice. Wow. Now let's move on. Do you know the difference between solubility and miscibility? Have you heard of these words? Solubility. What is solubility? Solubility is the ability of solid or gaseous solute to dissolve in a liquid solvent, thus forming a solution. For example, you have MSG or monosodium glutamate, or better known as Vetsine in our kitchen, is soluble in water. Black pepper is insoluble though in water. So solubility has something to do with the solute's ability to dissolve in a solvent. So if it dissolves, it is called soluble. If it does not dissolve in its solvent, it's called insoluble. In means not. So if it's insoluble, meaning not soluble, or it does not have the ability to be dissolved. What about miscibility? Miscibility is the ability of a liquid solute to dissolve in a liquid solvent. So for solubility, it is for solid and gaseous solute. But for miscibility, it is for liquid solute to dissolve in a liquid solvent, thus forming a solution. Example, soy sauce and vinegar. Both of them are liquids. Soy sauce is miscible in vinegar, so it dissolves in vinegar. What about oil in vinegar? Does it dissolve? Oil is immiscible in vinegar. Well, let's try to see if these statements, if these examples here are true, because we are going to have some sort of experiment. So I prepared glasses, some empty glasses. And then for solubility, I prepared water, black pepper, and MSG or Vetsine. For miscibility experiment, I prepared oil, vinegar, and soy sauce. So let's observe our video. I took a video of the experiment that I did earlier. I started the experiment by pouring into the solvent our solutes. In the first glass, I poured in MSG or Vetsine and stirred the mixture well. you can see that there are no traces of vetsine or MSG particles in the water. It is totally dissolved. This means that the vetsine or MSG is soluble in water. Next, I stirred into the glass containing a mixture of water and black pepper. Notice that no matter how much I stir the mixture, the particles of black pepper remained visible. They did not dissolve in the water. Thus, it means that black pepper is insoluble in water. Next, let's move on to the mixture of vinegar and soy sauce. As soon as the soy sauce reached the vinegar, they immediately mix together, that you cannot anymore distinguish which is which. Soy sauce is definitely miscible with vinegar. Now let's move on to the mixture of vinegar and oil. I tried to stir the mixture more and more, but no matter how much I try, the oil keeps floating on top of the water. Oil is definitely immiscible in vinegar. So you see, water and MSG are soluble and they form a solution mixture. Look at that. You see that? You have there the water and the MSG, the water, and the black pepper. After some time, I let them sit and then for a while. And then after that, you cannot anymore see traces. It remained stable. There are no traces of MSG in the water, but some particles of the black pepper floated on top of the water and some of them sunk onto the bottom. While for the miscibility experiment, still you cannot anymore distinguish the vinegar from the soy sauce in that mixture. But for the mixture of oil and vinegar, you can clearly see that the oil is floating on top of the vinegar. So look at the picture now. What's left are the mixtures of vinegar and soy sauce and the mixture of water and MSG. They are actually examples of solutions. Why? Solutions remain stable when left unattended. Their components remain evenly distributed throughout the mixture. See, you cannot identify the soy sauce from the vinegar. And you cannot say, oh, the vinegar is underneath the soy sauce. You cannot say that. Unlike the vinegar and oil, where you can see the oil on top and the vinegar underneath. And also the water and the MSG, you cannot anymore see particles of the MSG. Unlike the mixture of the water and the black pepper, wherein there are so many particles of the black pepper which are floating and some of them sinking at the bottom. So those are great examples of solutions that we can find in our kitchen. So remember these. These are the different characteristics of our solution. First, homogeneous or uniform in appearance, just like what you saw in our picture. There is only one unanimous appearance. Next, the size of the solute particles is extremely small. Yes, these particles cannot be seen with the naked eye, and even if you put the solution, those two solutions, under a microscope, still you cannot see the particles of those. And next, if you try to pour the mixture into a filter paper, the solution can pass through a filter paper without traces. And lastly, they look very stable. No components are separated. So those are the different characteristics of our solution mixture. Now, are you ready for our practice test? I'm sure you're excited. Let's have this practice test. What you're going to do is Put a happy face if the pair of substances are soluble or miscible. Meaning to say they can thoroughly mix. While put a sad face if the pair of materials or pair of substances are insoluble or immiscible, meaning they do not totally mix. Okay? Ready? Let's start. Number 1, water and margarine. Number 2, calamansi juice and water. Number 3, gasoline and water. Number 4, soy sauce and vinegar. Number 5, water and salt. Number 6, water and sugar. Number 7, vinegar and oil. 8, alcohol and water. 9, water and sand. And 10, water and black pepper. Are you done answering? Or you're still thinking, oh my God, do they mix thoroughly? Are they a homogeneous mixture or a heterogeneous mixture? Is it a solution or not? Oh, thinking. That's very good. Okay, if you're ready, let's check so you would know whether your answers are right or not. Number 1, water and margarine. It's a sad face. They don't mix together. The margarine would float on top of the water. Calamansi juice and water. Of course, smiley face. They can mix. They're soluble. They're miscible, I mean. Gasoline and water. Oh, sad face. They don't mix because gasoline is what? It's a kind of oil. Next, soy sauce and vinegar. Yes, they do mix. So you have a smiley face. Water and salt. Of course, a smiley face. They are soluble. The salt is soluble in water. Water and sugar. Smiley face. Sugar is very much soluble in water. Vinegar and oil. Oh, sad face. The oil does not mix. It's very obvious in our experiment a while ago. What about alcohol and water? Yes, it's a smiley face. Water and sand. It's a sad face. The sand would just sink underneath in your glass or in your container. What about water and black pepper? Oh, sad face. That's very obvious in our experiment, right? Count the number of check marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did you get perfect? Wow, excellent job. That's great. You're doing really, really well. But if you did not get perfect, that's okay. You can investigate if you're not, oh, why did teacher Jean say that it's a sad face? Let's see if they really do not mix together. You can do some experiments, investigations at home. That's what science thinkers are. They investigate, they think. Are you ready to move on? Let's go. For our additional activities, I want you to do the following in your activity notebook and then submit it later to our Google Classroom. Number 1, I want you to differentiate a solute from a solvent. So explain very well your answer. Number 2, explain how a solute is considered soluble. How can a solute be considered soluble? Number 3, how does a solute become immiscible? And number 4, list down 5 kinds of solution mixtures found in your home. So you do not list down those that we have already discussed. You cannot anymore list down those that I have already given as examples. You have to have your own examples. And number 5, what is a solution? You give at least 3 characteristics of a solution. Okay? So your total score, if you get perfect in this activity, would be 15 points. Okay? Are you excited to do it? I hope so. Now, before I end this video, I want you to look at this meme. It says, I like you, but we're from different states. It will never work. And then the solute said, and no, the solvent said again, we can't be together. And then the solute said, oh, but we can. And at the end, that was your solution. You mix the solute into your solvent. And so you're able to form a wonderful solution. Okay, so that's the end of our session for today, kids. I hope you have learned a lot from our lesson today. Please don't forget to like, share, and to subscribe to my channel. Until next video, bye-bye. This is Teacher Jean saying, take care, be safe all the time.